Okay, hello and welcome. This should be all live now. Firstly, I'd like to quickly apologize because I have hay fever. So, right now I'm not feeling the best, but hopefully everything should be fine nonetheless. Just a few prerequisites. This is paper 2 for OCR GCSE Computer Science. Because of the advanced information, it only covers paper 1. So that means paper 2 is covering all the usual content. So those people who are sitting exams later on, they shouldn't really be affected by this. So basically, the YouTube video applies to all exams later on and now. I'll start it off in a minute. Got some people coming in. Hello. In terms of questions, to make things a bit easier, I'll pause the stream. Sorry. I'll pause the stream at certain times, and at that time, I will take questions. I think it just makes things a lot easier. Pollen does have me messed up. Don't violate me like that. Okay, I'll begin in about 10 seconds. Sorry to the YouTube people who are having to wait through this, but, it's great. By YouTube people, I mean the people who are going to watch this as a YouTube video, not a live stream, by the way. Do let me know if there are any issues, but I think this should all be fine. Okay, I'm going to go... I'm going to have a quick drink of water, and then we're going to start. Okay, cool. So, let's start things off. Algorithms. So, that's the first topic. So, there's a thing called computational thinking, and it's pretty much thinking like a computer. So, the idea is that you take all the best... computational thinking is basically about the steps you take to find the best solution to a complex problem. So, a complex problem that a computer receives, it's an algorithm is basically a set of steps. So, you just go step by step to try and find a solution to the problem. There are 3 different things which are associated with computational thinking, and you need to know these definitions, and they do often appear. So we'll cover them separately. Firstly, we have abstraction, and that's where you pick out important bits of information from a problem, and you ignore the specific details which don't matter. So I think sometimes people find this quite tricky to understand, but we have a cheeky example here, which should be quite decent. So let's say you're making a movie poster. The main things you want... I probably should have put a photo of a movie poster here. But, movie posters, they have the title of the movie, and then they have, the actors in it, in their character form, etc. But you focus on the characters, the actors, the date of release, and the name of the movie. But the things you ignore, or the specific details which don't matter, is the synopsis, the date of production starting, the type of film. It can literally be anything. Anything which doesn't appear on the movie poster, or what shouldn't need to appear. Cool. Decomposition. So decompose, you guys might know this from biology or science in general. That's basically where you break things down. So if you apply this to computer science, is where you break down a complex problem into smaller problems and you solve them individually. So we have a little example here. So your task is you want to go on a weekly shop. You want to go to a shopping market. So you need to break this down into different problems. The first one is deciding on the budget. Then you need to make a list of items. Then you need to decide where to shop. Then you need to decide how to get there, and finally you actually need to do it. So decomposition is a pretty simple concept to understand. Finally, algorithmic thinking. A logical way of getting from a problem to a solution that can be reapplied and adapted to solve similar problems in future. So an algorithm, as we mentioned earlier, is basically just a set of steps. So you just need to think logically, how can I solve this? So here we go. So what do you do in the morning? So the algorithm starts by you waking up. If it's a weekend, you could have a lie-in. But if it's not, then you have to get up and go to work. So that has pretty much that. Cool. We need to know how to make flowcharts. So they might ask you in a 6 marker or a 5 marker to make a flowchart for something. These are the specific symbols that you need to use. So line is showing the flow of data, or the flow of the flowchart. We have this parallelogram, I think, and that's where you have inputs and outputs. So you can have input name. So that's where the user enters their name, etc. Process is where something happens. So you can do, for example, 5 plus 6. That's a process. Decision, that's where you can add loops and stuff. So if number is equal to 5, then do this or do this. Subprogram, this is functions and procedures where you input data and then something happens to that data and it's outputted. And finally, there's terminal. So that's what you use to start and end the program. Cool. So here are 3 different types of flowcharts. They often ask questions about this. So instead of looping, it should say iteration, because that's like the OCR term. But I just found this on the internet because it was easy. But a sequence is where you can only do one thing each time. So there's no choice. Like there's only one possible option to get from the start to the end. A selection, as the name suggests, is where you can select something. You have freedom to choose. So over here, there are two different choices which you have. And finally, looping or iteration, which is a word that you're going to need to use, is where you like go back over something. So, for example, we have a few examples later, but I'll give you a quick one. If the name is not equal to Danny, then you need to ask them to re-enter the name. So it goes down to decide and check, and if it's not equal to Danny, then it goes back up and around. So it just keeps asking you. Cool. Searching algorithms. Okay, I want to try and do something really cool here. I say really cool. I just find this cool. But I'm just going to use a piece of paper for this. So let's say on a piece of paper, we have some numbers. So the numbers on screen, -3, 5, 6, 8, etc. So there are a few different ways we can go about finding the position of 6 on this list. One of the ways, which basically everyone uses, is going one by one through the list, trying to find it. But what if there was a way that we could speed things up exponentially? We could go through things really, really fast. So the method that we could use to do that is we go to the middle of the list and we see if the number in the middle is bigger than the number we're looking for, we have to get rid of the right hand side in that number because all those numbers are bigger, so we won't need to look at them. But if the number in the middle is smaller, we can get rid of that number in the left hand side. So what does that do? It rips apart the entire list. I'm so proud of that. I nicked off CS50 if any of you guys know about that. But basically what it means is you can keep splitting the list apart. So you can keep halving it. And as you keep halving it, you just keep getting closer and closer to the actual number. So it's called binary search. So here we have the numbers. We see that the middle number, so you go to the middle and you compare it to the number that you're looking for. Because 8 is bigger than the target, which is 6, you get rid of the right hand side and that number, because all the numbers on the right hand side, because it's a sorted list, they'll all be like bigger than that. So you can get rid of that. And then we're left with this list, -3, 5, and 6, and we're trying to find 6. 5 is less than 6, so we can get rid of that number and the left hand side, because all those digits are smaller. And finally, we find 6. So the advantages to binary search is that it's very, very efficient. You just keep splitting it each time, and it means it's very fast, especially for large lists. But the disadvantage is that it only works on ordered lists, because if we're like splitting apart half of it, we need to be certain that all the numbers are bigger. Otherwise, we've just like skipped over random numbers. So it only works on ordered lists, and also it might not be as effective on smaller lists, because if there's a very small list and you need to like half it 2 or 3 times, whereas if it was linear, you could just search through it, which would be pretty quick. So yeah, binary search, use it with large lists, maybe not with smaller lists. Linear search, the one that everyone knows. Linear means like to go through like a line. I don't know if you know about it in maths. You just go through one by one. So here we have 4, 1, 3, and because we're looking for 3, 3 has been found, so it's like in yellow. The advantage is very simple. It works well with small lists, and it works on unordered lists as well, which makes it quite useful. The disadvantage is it gets very slow and inefficient, especially with long lists. Bubble sort. So this is where you have some numbers. I also should mention that this applies to words as well, so alphabetical order, etc. But yeah, you have a list of numbers or a list of words, and you have to sort them such that it goes from smallest to biggest, or biggest to smallest. So with bubble sort, how it works is it looks at the first value and it looks at the second value. So if we're trying to go from smallest to biggest, if the first value is bigger than the second value, it swaps. So it just keeps going through each one and swapping. So here's the original list, and because 8 is bigger than 5, they swap. And then they compare 8 and 2. 8 is bigger than 2, so they swap. Then they compare 6 and 8. 8 is bigger than 6, so they swap. But 8 and 12, 8 is not bigger than 12, so they don't swap. So this is the first iteration, it's known as, so it's the first time they've gone through it, and then they just repeat that. And they keep repeating that until the list is in total order. The advantage of this is that it's pretty simple to do, like anyone can do this. It's efficient to check if a list is already ordered, because you only have to go through it once, and it uses very little memory, because it just keeps within that one list. It doesn't make extra lists. The disadvantage is it can be quite inefficient, especially for long lists, and yeah, as I mentioned, just beneath that. Doesn't work well with long lists. Merge sort. I don't know why this exists. I can't lie. I really don't like merge sorts, but it's in the spec, so we have to cover it, and it probably will appear in the exam because it hasn't appeared in past papers. So pretty much how it works is you keep splitting the list apart until each value has its own list. So as we could see here, each number here is its own list. And then when you put them back together, you just compare them. So 1 and 5, because we're going from smallest to biggest, 5 is bigger than 1, so we can put it back normally. 2 and 6, 6 is bigger than 2, so we can put it back normally. And then we go again, and we just keep putting it back. So this time we also include 3. Because 3 is bigger than 1, but smaller than 5, we put them between each other. And 4, 2, and 6, 4 is bigger than 2, but smaller than 6, so we put it in the middle. And then the final one, you just put it all together and you compare them. So the advantage of this is that it's quite efficient. It's quicker than bubble sort, and it's got a consistent runtime. No matter how long the list is, the runtime will always be the same pretty much. The disadvantage is that it's quite slow for small lists because you have to keep splitting them apart and stuff, and there's just very few numbers, which isn't really needed, but it's a bit annoying. It goes through a huge process, even if it's already sorted. So if a list is sorted and you want to check that it's sorted, it will take a lot of time, which is a bit long. And finally, it requires a lot of memory because each value has its own individual list. Insertion sort. Now this one is quite nice. I quite like it. So pretty much how it does is there are 2 separate lists. So here's the initial list. And then on the left, a new list is made. This is green. So what it does is the first value is in the list, and then it looks at the next value, and it puts it in the list based on the previous values. So 5 is the first value in the list, and then it wants to add 4. So 4 looks at the list, and it says, I'm smaller than 5, so I'm going to go before it. And then 2's there, and 2 says, I am smaller than 4, so I'm going to go before it, etc. So they just keep comparing each other, and the new value enters the list based on what it is. The advantage is that it's very easy to code, and I quite like insertion sort. It's like the middle child in a family. It just exists. It's not really that relevant, but you know. It works well with small lists, and you don't really need much memory because you're only using 2 lists in total. It's very quick to see if a list is already sorted because you only need to go through it once. But the disadvantage is that with large lists, it can be quite long because you have to go through each value. Okay, I'm going to take some questions now because we're moving on to the next topic. There's a lot of stuff here, so do bear with me. Within each flowchart symbol, do you write the instruction title in pseudocode? So as in like sub process and all of that? No, you don't need to. All you need to write is what's actually going on. But yeah, so you can use the symbol, but you know what, let's go back to it for reference so you guys can understand this a little bit better. Here we go. So you don't need to write what's actually going on. Like for decision, you don't need to write decision in there, and then you can write like the operation. You don't need to write decision. You could just write the operation. Quick question for paper 1. Okay, I'll take a quick question for paper 1. When binary shifting, do you just add zeros to the empty space? Yes, you do. Cool. And I am going to be posting this later. Okay, that's fine. Let's go back. If you have any other questions, please put them now. Is trace table going to be on the test? There's no advanced information, but there's a high, well, I say high possibility. There's definitely a possibility of it appearing because it is in paper 2. It's in the specification. Any other questions, or I'm going to move on to the next bit? Seems all fine. Yeah, the PowerPoint. Oh yeah, if you want to see the resource, I got feedback from last time and you guys really like the resource. So I've already put it into the description. So if you want to look at it separately, you can do so. I've got a prefix in my name. Lovely. Okay, great. Programming now. So we've already finished. That was all of topic 5 and we speedran that. So that's pretty good. Topic 6, programming. Now, most of the time at school, you should be doing programming with your teacher and stuff. So it'll be quite hard for me to teach you all of the programming you need to know from 2 years, can I say. But I'm going to try. So I put them into tables. So this is the first thing. This is simple stuff you need to know. So an integer is a whole number. The code for it, like the little symbolic representation of it, is int. And the examples are 24, 5, minus 23. And you need to know the amount of memory used for each one. So if you have the number 24, either 2 or 4 bytes will be used to store that. Then you have floats. This is basically whole numbers, but you can use decimals as well. So here we have 3.26, 4.85, If it's just the number 5, but you store it as a float, it'll be stored as 5.0 because there has to be a decimal place. Floats are obviously the biggest because they're probably going to hold the most like value in terms of how many numbers there are, which you need to remember. Boolean, bool, it's got quite a nice name. It's either true or false, 0 or 1. Those are the only two states possible. So here we have some examples, true or false, 0, 1, yes or no. It's very, very small because there are only two possible states, so 1 bit is needed, but most of the time in computers they use 1 byte because it's just easier. Characters, so letters, numbers, symbols, special characters. So this can be like most stuff. You can even store numbers as characters. So you can't like add them together. If the numbers are stored in character form, we can still use them. And they are 1 byte. Only 1 byte is needed. So 1 byte for each character. String, that's a collection of characters. So here we have the example, Mr. Potential. So that's a collection of characters. You can have spaces and stuff if you want. You could put a sentence in there. You could use different symbols. Yeah. And the memory used is 1 byte per character. Cool. Converting data types. So you can convert things between different data types. So if we have 1 as a string, you can put that into sentences, right? But you can't do operations to it. So you can't add the 1 to something else because it's in string form. So if we want to be able to add it and do other operations, we need to convert it to an integer because that's the actual data type for a number. So the way we do that is we do int, and then in brackets we do 1, and the quotation marks, are used to show that it's a string. So strings always have quotation marks, as we saw here, but numbers, floats, and booleans do not. Boolean, so if you have a 1 or a 0, a true or a false, you can convert that to Boolean form. So it will always be either true or false. We have real, so if you have the integer 1 and you convert it to a real, it'll be stored as 1.0 because reals or floats always have decimal places. String, so this is where you convert something to a string. So if we have the Boolean true, so reminder, Boolean can either be true or false. If we convert it to a string, it would just be the word true, and it won't have the value of 0 or 1. Ascii, so we'll talk about this. Actually, this is a paper 1 topic, Ascii, but you need to know that in paper 2 you'll be able to convert a letter to Ascii form and vice versa. So if you do ask B, you find the Ascii number of B. Same goes for character. If you have the Ascii number 98, you can convert that back to B. I feel like they'll have a question on this, like making a program where users can input the numbers and it like converts between or whatever. But yeah. Maths, arithmetic is known as arithmetic. That's just a fancy word. I think I used that in about year 4, and then we started using mathematics because we're cool like that. But yeah, most of the stuff is just normal. So addition plus, subtraction minus, multiplication. You have to use the star sign instead of the x because x can be interpreted as a string. You don't want all that. Division. You have a single division line, and here we have the division there. Exponentation. That's just powers and stuff like that. So 2 to the power of 2 is 4, etc. You can either do that using the upwards symbol or the 2 stars. I usually use the 2 stars because that's what we use in programming languages, but upward symbol works fine. Div. Now this is where you divide a number and you only get the remainder. So the example here is 20 divided by 3. If you do 20 divided by 3, you get 6. Sorry, I've already goofed again. When you divide it, if you do div, then you get the whole number. So 20 divided by 3 is 6, and they ignore the remainder. But with modulus, you only get the remainder. So I'm sorry, I botched the explanation a little bit there. But yeah, 6 times 3 is 18, so there's a remainder of 2. And if you do modulus, you only get the remainder. You don't get the actual value. Computers also use BODMAS or BIDMAS, whatever you like to call it. So you need to keep that in mind. You might need to use some brackets in some of the questions. Comparison, crocodiles. I've put crocodiles there because you can have crocodiles bigger and smaller than, etc. So you can have equals to, not equals to. I like this. I really like this. Exclamation and then the equals. I don't know why, but I'm a big fan of that. But yeah, you can have the crocodiles saying which one are they going to eat. Cool. Constants and variables. So you could either have things stored as a constant or a variable. Data values can either be constants or variables. And the name of the value, this is a bit like in depth, but the name of the value is linked to a memory location that stores the value. So if you say number is equal to 5, the word, or like the the data of num will be stored at a memory location. So number 5 will be stored at the memory location, which is associated with the variable num, if that makes sense. I don't think you really need to know that, but it might appear. I don't really know. Constants cannot be altered when the program runs. Guess why? They're constant. Constant means it doesn't change. So the example here is that we have a constant. We assign a num to the number 5, and it's a constant. If you try and add to it, it just won't work. It'll return an error. But variables, they can vary. They could change. Sorry, I made another mistake here. I did make this at like 3 a.m. by the way, so that's my excuse, but I shouldn't be making mistakes here. But if you put variable in front of that, then the number will be equal to 6. So string manipulation. This is another topic which appears quite frequently. So you need to know all of these different functions. Upper, guess what it does? Turns it to uppercase. Yeah. So it changes the string to uppercase. So the example here is you have the name Yiggy, and what does it do to each thing? So name.upper would turn Yiggy into Yiggy with capital letters. Lower obviously turns into lowercase. Length returns the length of the string. So I'm really having a bad day. That should be 5. I'm a bit stupid sometimes, but just let me live. Name.left x. So the x being the number of characters. So the example here we have is name.left 3. So it looks at the first 3 characters from the left to the right, and it will be Yig. Okay, someone's quickly put, you missed trace tables in 2.1. Trace tables are like, they're too simple. I thought there wasn't really a need to cover them. I'll probably look at them in the end if really needed, but it's really like, it very much makes sense. Like trace tables are like, they give you a flowchart, and you basically have to just use your head and put a number in the flowchart and guess what the output is going to be. I say guess, you need to work out what the output is going to be. But yeah, I'll probably cover that afterwards. Name.right, so that's where it starts from the right and it goes to the left. So name.right 2 would go to the very right letter, and then it will do that letter and one more because it's 2. So 1, 2. Name.substring A, B. Now this confuses a lot of people because they think it's between those 2 values, but it's not. It's where a new string is created where it starts at A, so the value A, so it would be like, for example, here we have 3, so it'll start at the third value here, or whatever, third character, and then B would be how long it lasts. So if it starts at 3, that'd be G, because it starts at 0, 1, 2, 3. Go to 3, and then it'll add 2, so it'll do 3 and 4, 5. Cool. If statements. So here's a listed example here. An if statement is where if something is true, or if something, you could basically just say if something is true or if something is false, then the program has to do something. So the example here is that you input your name, and then the program decides if your name is equal to Ravishan, so this is just something I've created, it will print cut your hair. I think that's valid. Else, you can also add an else. So if that isn't true, then you could just say, hey, how are you? You have total freedom with the program. You can also do an else if. So the first condition is if your name is Ravishan, that happens. Otherwise, another condition is if your name is Danny, it prints potential, because that's what I wanted to do. And then otherwise, nothing happens. So if those 2 conditions are not true, then this is printed. Hi, how are you? Now, we can also do nested if statements. So this is an if within an if. So this is where you have like multiple things need to be true for something to happen. So we have the example here. You input your favorite game and you input your favorite anime. And I say, if the game is equal to Minecraft and the anime is equal to Attack on Titan, then it prints. Love to see it. You can also have else's within this. So if it, I don't know why that's capital letters. Probably because it's just autocorrect because I'm using slides. But yeah, within the nested if statements, you can also use else's for each one. And you can keep it contextualized. So if the anime is not the right one, then you can say pick a better anime. And if the game is not the right one, then you can say pick a better game. Switch statements. So this is with OCR reference language. So we have driver equals input. So this is very similar to if. So basically just checks what the value is. So driver is equal to input, enter your favorite F1 driver. Switch, and then the case is each different value. So if the driver is equal to Gasly, then you say, you know the way. If it's equal to Hamilton, then you say, you're a glory hunter. If it says Verstappen, you started watching F1 last week, shush. Norris, I rate it. And default. Default is where people often mess up. Default is where it isn't one of these conditions. So if it was someone else other than this, it will say, who on earth is that? And then end switch. So the disadvantage of this is that it can only check one variable. Cool. For loops. Hold on. I'll probably stop it here in case people want to ask questions, because there's quite a lot here. I do have to fix my sleep schedule. This is not theory. This is programming. Thank you. Someone said I've explained this well. It's casting in the spec. So casting is where you put something into a different data type, and yes, that is in the spec. Please do some write and algorithm questions. Okay, I think I'll make a separate video literally after I finish the live stream, and I'll quickly speed run a few questions. You don't get a calculator in paper 2. You don't get it in paper 1 either, but most of the math is very simple. Exam board said they're marking generously. Do you think this will make any difference? Yeah, I think marking generously basically means if you're slightly off with your answer, they'll still give you the mark, but I'm not an expert in this by any means. So, yeah, I need to fix my sleep schedule. Everyone's just happy that I violated revision. Can't you make it short, Elif? Yeah, that depends on the language. Some languages don't allow that. So, you might want to refrain from using it. But I'll look at it a bit later. With Section A and Section B, there are different languages which are permitted to use. So at school, most of the time, you learn a high-level programming language. So that can be Python, JavaScript, etc. So some of them use elif and some of them don't. My teacher told me to use then instead of a colon. Right, so with the high-level programming languages, you can use a colon. And with the normal ones, you can use then. I'm pretty sure it's said in the specification somewhere that if there's a slight syntax error, it doesn't matter that much, and they won't dock marks, so it should be fine. Sorry about my hay fever again. That's pseudocode. Pseudocode, pseudocode OCR reference language, they now call it, because it's not pseudocode. But yeah. What's the difference between switch and if statements? So with switch statements, you can only use one variable. So switch driver, the only variable that we can compare is driver. So we have to see if driver is equal to everything. But with this, we can use multiple variables. So we can use game and we can use anime. So it just gives us a bit more freedom. No, marking generously just means the grade boundaries will be lower. Maybe. I'm not really sure. Can you use else? Can you short else if for elif? I would not do it. Actually, I don't think it's that deep. Because they are the same thing, but I don't know if the examiners will care that much. I'm not really sure, but you'll probably be able to get away with it. That's my prediction. Okay, any other questions? Put them here. But I'm going to move on to the next part. For loops. So for loops is for a condition. You have to do something. So what we often use. This is just the one that everyone always uses. So for I equals 0 to 5. Print high. So this is quite hard to explain, I can't lie, but basically what it does is it makes I equal to 0, so it assigns a new variable, and then it does something, and then it increases the increment. So I starts at 0 and it goes all the way to 5. So with the first one it prints high, with the second, and then it increases its increment to 1 and it prints high, and it keeps going. So because it's 0 to 5, it does the output 5 times. Cool. You can also print the I value. So this demonstrates what I was talking about earlier. Each time it loops around, it increases the increment of I. So the I increases by 1. So it starts at 0 and it goes, because it says 2, 5, it only goes up to 4. I can't really explain it that well, but after it goes around, so let's say it's number 4, and then it prints, and then it goes around, and now it becomes 5. Because it's gone to 5, it stops, if that makes sense. But yeah, it's sort of, it just doesn't go to the final value. We could also loop using, it doesn't have to be an integer. So here we have games. This is a list, and it has 4 different games in it. So we could use 0 to games.length, and that's because games.length is an integer. It'd be 4. So it'd mean from 0 to 4. And as we said earlier, it'd only print out the first 4, but they'd be only going up to 3 because 0 is first. Do until. So this is where it does something until a condition is true. So continually, it asks to input what is the best team in Europe. And it does this until the team is equal to Arsenal. So if you put like Chelsea, then it will ask you to input the team again, and it'll continually do that until it's equal to Arsenal. We have a little flowchart representation. So if the condition isn't true, then it repeats that part of the program. While loop. So this is very similar to do until. So yeah, I've used pretty much the same example. So you input a team, and then while this means not equals, as we looked at earlier. So while the team is not equals to Arsenal, you have to input it again. So these two lines continually repeat, and then when it is equal to Arsenal, it breaks out of that loop because the condition is now true. So you can run the next bit of code. So here's how it works. If it doesn't, if the condition is true, then well, this in this one we're doing if the condition isn't true. But yeah, Arsenal's the best football team in the world. Obviously, you know, I'm gonna get violated so much for this. I do support Arsenal, but I wear it with pride. Boolean Logic. This is the most free marks you're ever going to get in a computer science exam. Like this is, I love Boolean Logic so much. It just makes sense. So there are 3 different shapes which you need to know about, 3 different operations. So we have and that's where 2 things need to be true. So A and B need to be true for the output to be true. I'm going to look at this a bit more in a second. Or, where it's A or B has to be true for the final output to be true. And finally, not. So if something is true and it goes in, then it does the opposite. So if I am happy, go in, I become sad. I'll try to explain it like that. So here's the OR gate. So we have A and B. Those are the 2 inputs. If it's both 0, neither of them are true. So the output will be 0. If either of them are 1, it will be 1. And if both of them are 1, it will also be 1. Because it's been fulfilled. This is what it's drawn like. You need to know how to draw these. It's very simple. It's very, very simple, but you need to know how to draw these. The AND gate, this is just where both values need to be true. So if A and B is being inputted, A and B must be true for the output to also be true. Otherwise, it will be false, 0 and 1. Yeah, they always use 0 and 1 in Boolean, because Boolean could either be 0 or 1. Not, this is very simple. If it's 1, then it turns to 0. If it's 0, then it turns to 1. It just does the opposite. Here is a question which I thought was quite interesting, because I went through a past paper and I was like, yeah, I should probably let these guys know. They can combine Boolean logic, so they can get different structures and put them all together. So this is the OR, this is the NOT, if you can remember from like a minute ago. This is the AND, this is the NOT. So what we're looking for is the correct logic diagram for P is equal to not A and B. So the brackets mean that's done first, as we know from maths. So we have to find first it does A and B, and then it does not to that. So we don't need to know about XOR, that's A level. But yeah, so A and B goes in, so that's and then it does not to that. So this would be the answer. Cool. Logic circuits. So I'm not going to... Wait, have I put the answer here? Oh yeah, no, I have. So you have to draw a logic circuit for A or B and C. So because of the brackets, obviously, you have to do B and C first. So how I do it is I line up the inputs on the left, all one after another. So A, B, C. And then I'd have the AND for B and C. And then the OR for the output of the and A goes in. So here's what it looks like. So B and C, it does the and then A and that output goes in. And the output finally is P. Cool. Logic in code. So you can also use this in code pretty much. You just use Boolean logic in code. So this is what it looks like. You can do and or not. And not goes in the brackets. Arrays. So array is a data structure used to store a collection of data under one name. So for a one-dimensional array is a list, which we talked about earlier. So games is an array, or you can call it a list. So FIFA, Fortnite, GTA. So one-dimensional arrays are basically like lists. But imagine there was another dimension. Woo! So I've used this because it's a decent example. Is this a decent example? Yeah, it is. Okay. So this is the first value of the list. The one that you should be able to see my mouse. I think you could see my mouse. I'm not too certain. But this is the first value of the list, and this is the second value of the list. So it's displayed in... this is like a visual representation of it. But the first value of the list, it'd have 1, 2, and 3. So that's the first dimension. Well, there are 3 dimensions here. So the first dimension is the left, the second dimension is the middle, the third dimension is the right. So it just goes one after another, sort of. So the more like values within each value of the list you have, the more dimensions there will be. So if it was FIFA and then another value like 22, and then that's one value of the list, then it goes to the next value of the list, that'd be 2 dimensions. But because there's 3 here, it's 3 dimensions. That sort of explains it. Yeah, that's arrays done. Files. You need to know 5 different operations for files. You need to know how to open it, read it, write it, check if it's the end, and close. So to open it is basically like assigning a variable. So file is our new variable, and we say it's equal to open games.txt. So that's our text file. To read the line, we do new equals file.readLine, and what that now means is the variable new has the data of that line stored within it. So if we want to read it, like if we actually want to output it, we just do print new. Writing, we do file.writeLine, and you can put anything within that. Please keep in mind the capitals here. So it needs to be read lowercase and then line with a capital L. End of file. So end of file is a Boolean. It can either be true or false. You can either be at the end or you can't be at the end. So if you're at the end of the file, you can do like an if statement. You can print the file is now finished. And you could also do like else, the file is not finished, and close, file.close. So file.closed is this file, and it's just closing it. You need to remember to close the file, otherwise you will lose marks. Cool. Records. So records, I don't know if you guys know object-oriented programming, but it's quite similar to that, I'd say, somewhat. I don't know, I've probably brought to that. But records keep related information in one place. So the record for a player, and this is all the data stored within that record. You have the name, you have the age, you have the height, you have the nationality, and you have the Ballon d'Or winner or not. So the data type you have to also declare beforehand. So it will only accept a string as the name, only an integer as the age, a float for the height, a string for the nationality, and a Boolean for Ballon d'Or winner, because you can either be one or you can't. And it ends the record there. So let's say we want to make a new record for a player. We can have Ronaldo. We could say his name is Ronaldo. His age is 38. His height is 6.1. There should not be speech marks around this because a float does not require it. I apologize. The nationality is Portuguese, and the Boolean value is true because he is a Ballon d'Or winner. Yeah, that's pretty much it. All you need to know for records. SQL for data. So there's 3 different things which you need to know with SQL. Select, from, and where. And you just combine these to get data from a database. So here is the database that we're looking at. I've nicked this off some random website, so I do apologize. But yeah, that's the table. You'll be given something similar to this in the actual exam. And let's say we want to find the name of the monsters who have an XP which is greater than 249. What it does is it looks at the table. So the table is called monsters. And then it looks at the XP and it sees who's got an XP which is bigger than 249. It's the ogre and the red dragon. And it then selects the name from there. So the output would be ogre and red dragon. Now there's also another thing which you need to know. There's a star. You can use select star, and the star is where it returns all the information. I presume if there is a question about SQL, you will need to know about star. I think they're going to ask you about that because people often trip up. So if you do select star from monsters, which is the table will always be the same, I'm pretty sure, in the exam, because they won't ask you to use a different table. But yeah, where is just a condition. So we've changed it a little bit, where x is greater than 99, and we can have multiple conditionals, and loot is equal to gems. So we can see that the only 2 is the goblin shaman and the red dragon. What it would do is it output all the information about the goblin shaman. It would output its name, its level, its loot, and its XP, and it would do the same for the red dragon. So star means output everything. It's called a wild card in the actual terminology. This is where you can have it output multiple things about it. So star does everything. You can also have 1 or you can have 2. So here we have name and level. So this is the same thing, but it only output the name and the level of that person, that character, the monster. Subprograms. So there's 2 different types of subprograms. There's procedures and functions. So the difference between them is that procedures don't take a don't require a parameter, but they can take one. So a parameter is where data is inputted to a function or a procedure or a subprogram. So a parameter is just something that's inputted. Whereas functions, they take a parameter and they always return a value. So parameters are variables used to pass values into the subprogram, and you could specify the name, data type, and the default value. So if no one inputs anything, then that's what the default value will be. Arguments are actual values taken in when the subprogram is called. So when we actually put something into it, it's known as an argument. So here is a procedure and here is a function. I was going to do a spot. I was going to do some interaction, but you guys had to spot which one was which, but I guess not. So the procedure here is welcome, and all it does is when it's called upon, it will print those two things, hello and welcome. Let's learn about procedures. A function, on the other hand, takes two parameters, so x and y, the parameters, and then when we call upon it and we put in data, those are known as our arguments. So arguments are used when we're inputting stuff, and parameters are used when the function is like being declared initially. It says that those are the things that it needs to use. So with this function, it would take in x and y as two integers, and then it would put them together and put a space between them. Cool. So there are two types of variables. There's global and local. Global is where it can be used within the entire program, and local is where it can only be used within the structure they're declared in. So a local variable, let's say if it's declared in a function, as we have here. So we have a function which adds two numbers together. Because it's declared within this function, the variable new cannot be called from outside. So if you exit this function, so if we like leave the function, then we try and print that value, it would return an error, because in the global world it doesn't exist, but within that function it does exist. If we put the word global before new, then it would have been fine, it would have worked. Cool. We're on to the final topic now. This is structure diagrams. So what is a structure diagram? A diagram showing smaller tasks in a larger program. That's pretty much what it is. So you have a large program. You can do the shopping list idea from earlier, and it just breaks it down, and you have to program each bit separately. So why would you want to use it? It improves the organization, and programmers can work on sections at a time. So it's a little bit low quality, but here is our diagram. The initial thing that we're working on is a message encryption system, and we need it to encrypt and decrypt. So we split that up into two different things. And then we need to break that up once again and do the specific things which need to be coded. So for encrypt, the input message, the encrypted message, and the output message. And for decrypt, it's the same thing. So the advantages is that coding is a lot easier because each part is now simple and broken down. Lots of programmers can work independently, and specialists can also focus on specific ideas, which is quite good, which I haven't mentioned there. It's easier to test things individually because you can test each function separately. It's easier to spot issues, fix them and update them, because you can see which like part of the program the issue is associated with. And finally, you could reuse subprograms in the future. So one of these things here, like the input message, you could just use that once again in the future for a different program. Maintainability. Okay, in the exam, this always comes up, and this is like, it's just a question which they love to have because it's pretty simple to do. And all it is how do you make code more maintainable? And these are the four answers which I always use. You can add comments which explain key features of a program. So to declare a comment, it depends on which programming language you're using. It could be a hashtag, it could be 2 slashes. And with that, the code doesn't run, but it's pretty much just basic English. So you can just do the 2 slashes and write whatever you want. So above a bit of code, if you put 2 slashes and write like, hello, my name is Danny, that won't print or anything, but that will just be there. So if someone's like reading the code, they'll be able to see that. Indentation, it makes control flow clearer. So indentation is where something is like indented, so it's moved forward. So here we have, this is actually an example of indentation. So this is a child of this. So it's the explanation has been indented. So the explanation of indentation has been indented. Variable names, you can make your variable names like relevant, and it makes it better for understanding. Because if you use a random variable name, then it's going to be hard to understand. But if you use a variable name which is like, it actually makes sense and is relevant, then it will be easier to understand. And finally, subprograms. So if you split up code into just different subprograms, it makes it a lot easier to work with, and you can mess things around a lot easier. So it makes code more understandable as it's like split up. Defensive design. What is defensive design? Defensive design is where programmers protect their program. So how can you do this? You can predict how the people are going to misuse it, and you can basically just try and think of ways to combat this. You can also ensure the code is well maintained, as we mentioned earlier about maintainability, and you can reduce errors through extensive testing. So if you do a lot of tests, you can see where errors might appear, and then you can obviously think of ways to reduce them. There are two methods which are mostly used for defensive design, and that's input validation and authentication. I'll go into that in a minute, so I'll quickly check if there are any questions. Yeah, trace tables are pretty simple, so I won't really mention them here. What topics in the specification? You need to know everything in the exam because there's no advanced information this year. When answering writer algorithm questions, you write in all caps. Not really. I don't think it's really that necessary. I'm just doing a past paper. Do we need to know the encryption process for J277? So encryption is where it's scrambled. I think that's 1.5, so I don't think you need to know it. But there's no harm in doing so, I guess. Yeah, someone says no, early prevention method, so it's not that deep. How does an array differ from list? So with list, it can only be one dimension, so that can only be one word and like each separate value. But with an array, you can have multiple dimensions. So you can have two things in each value. So you can have like the name of something and the date it was made. That's for each value. Does anyone have any practice papers for J277? Yeah, revisionworld.com has basically all of them. So I would highly recommend checking them out. Cool. If you have any other questions, put them down. But I'm going to continue on now. Right. So methods, authentication, and input validation. So there are 5 different checks which you can perform when you're doing input validation. And input validation is basically just checking that the data that's being inputted by the user meets certain criteria which you designate. So range, so that's like the range of different things which you would allow to be inputted. So if it's not within that, then obviously you won't let it go through. Presence is whether there actually is data inputted or not. So if someone inputs nothing, then obviously the presence isn't there. So it checks for that. Format. So example is the date. What's the format of the input? Some people might want it to be specific, like a word and then 2 dots and then another word. For example, you can check that it matches that. Length. So the acceptable lengths of the input. So you could say, for example, the word can be a maximum of 5 letters and a minimum of 2 letters. And a lookup table. So this is quite niche, but it's basically where you have a table and the data can only be one of those things from the table. Authentication is where the user identity is confirmed before they're able to access certain areas of the program. They usually do this by also having strong passwords and a max password limit. So that basically means if people are using strong passwords and a max password limit, then it's much harder for them to cheat their way through into the program. Okay, testing. Syntax errors and logic errors. You need to know this, and this does appear very, very often. So a syntax error is where there's an issue with the grammatical, basically where the interpreter doesn't understand something due to the grammatical mistake. So the example here is print hello. You forgot the T, so the compiler won't understand what's going on. They won't understand the code. Logic errors are slightly different, and that's where the program does run, but it does something unexpected. It's not what you wanted to happen. That's because there's an issue with the logic of the code. So the example here is that you do new is equal to x plus 1, print x. So what could have been the issue is they should have printed new instead of x. So yeah, that's just a logic issue. They made a mistake there. So just to reiterate, syntax is where there's a grammatical error with the actual code, how you've written it. And logic errors is where there's an issue with the logic of the actual code. How can you diagnose them or find them or deal with them? So syntax errors are usually diagnosed by the compiler. So after you try and run it, it tells you what's going on, and it tells you the issue. They also return the location of the issue. So it usually tells you which line this is on. So it tells you line 37, there is a syntax error. Logic errors are harder to track because the compiler doesn't really tell you anything about it. But if you've used comments and made the code maintainable, then it might be quite easy to find. Iterative testing and final testing. So those are the 2 different types of tests which you can do. So iterative testing is where the program is tested while being developed. So they're just continually tested and tested, tested, fixed until it's perfect. Final or terminal testing is where at the end of the development process, the program has now been made, then it's tested. So that's pretty much all you need to know about those two. You might be asked to compare them. Should be like 2 marks or something, so that should be fine. A test plan. So that's a plan of how you're going to test. So it outlines exactly what you're testing and how you're planning on doing so. So a good test plan anticipates potential issues with the program, and you basically put them in and then see what the output is, and you might need to make some fixes based upon that. Cool. Test data. So there's 4 different types of test data. There's either normal, boundary, invalid, or erroneous. A lot of the times I get confused with invalid and erroneous, but hopefully you guys don't. So the example is enter a number between 1 and 20. Normal would just be like a normal input, like 15, because that works. Boundary would be a number which is on the boundary of those limits, so either 1 or 20. Invalid is where it's the correct data type, but it should be rejected, because it doesn't like fix within it. So if you do like 57, that's not within the constraints. Erroneous is where it's the incorrect data type, and obviously should be rejected. So that can literally be anything which isn't an integer. Someone in the comments mentioned null, so that's where like nothing is entered, null. You could also do that type of test, but that wasn't in the spec, I don't think. Okay, high and low level languages. So high level languages, low level languages, and executable machine code is what we have here. Machine code is zeros and ones, that's binary. Here we have a little example. So high level is where it's not really, so, okay, let's try and think of how I can explain this. High level is very easy to understand, because it's basically English. Like, it's just simple English, and it all makes sense. Everything, every like keyword that you have to use when programming, it has a definition which makes sense to you. Low level is where you need to like really get into the nitty gritty. That's where it's like there's very limited functions, and you have to do things mostly all yourself, and it's quite hard to use. I've got a comparison here anyway. This is the table. It's a huge table. You're going to need to memorize quite a bit of this. So high and low level. So with high level, one instruction, so as we see here, like return or class, that represents many lines of machine code. So it basically just simplifies things. Whereas low level is where one line is one line of machine code. So instead of writing zeros and ones, you can use like basic English for low level. And that just represents one line. The advantage of high level is you can write code once and it works with many processors and machines. But with low level, code only works with one type of machine or processor, and that makes things really, really strenuous, and that's why people don't use them as much. High level is very easy to read and understand, as you can see here. That sort of makes sense to you if you're just a GCSE student. But low level, I don't really know what's going on there. So it's quite difficult to read and understand. Eternal structure. With high level, you don't need to know anything about the eternal structure of the CPU. But with low level, you do. You need to know how the CPU works. So the CPU loads data, and then it multiplies data. I don't even know what's going on there, but the CPU does that. Also, the high-level code, it requires translation before a computer understands it. So because it represents many lines of machine code, and it's very easy for us to understand, there's like a translation process. So the code is first translated into low-level, and then it's translated into machine code. And then the computer can understand it. But with low level, there's no need for translation because the computer understands it. It's very quick to convert. High level, there's less control over the CPU, so it's often slower because you don't really work with the specific like nitty gritty of the CPU, and you don't need to know its memory structures. It means you have less control. But if you know its memory structures, you know exactly how the CPU works, you have more control, so you can make it a bit faster. Cool, translators and compilers. So they're 2 different things. So a translator is where you have a bit of code and the translator converts it all at one time into a exe file. So it translates all the code and it converts it. A compiler, on the other hand, runs it in real time and it goes line by line. So it reads code line by line and then runs it. With translators, a few features is that after you've clicked run, it creates the exe file, it translates all the code, and it returns a list of errors for the entire program. But with compiler, because it's going line by line, it returns the first error it finds, and it doesn't continue. With translator, compiling is a bit longer because you have to convert it all at once. But when it does run, it's very quick to run because it's all converted already. But with compilers, it runs slowly as it's all done in real time. Let's take a little break to see if there's any questions. What programming language do you do? Okay, at school I do Python, but at home I'm learning JavaScript and Dart, which is pretty interesting. There doesn't seem to be too many questions, so things are going better than last time, I'd say. A bit better than last time, which is a relief. Less mistakes. We won't forget the hexadecimal mistake. Anyway, an integrated development environment. So that's a software that helps programmers develop a program. So it's pretty much just like a software which you can use, and you can write code in and stuff like that. And it just provides you with tools to help. So a common example is VS Code. That's the one that a lot of people use. There's also idle. But yeah, that's mostly it. The different features there are is syntax completion, and that's where you use AI to predict what you're writing, and it gives an option for you to autocomplete. So you might have seen it before when you're typing like an IDE and you're saying print something, and it sort of predicts what you're going to want to print, and it allows you to just click one button and it autocompletes it for you. So if there's a question, there's often like 4 markers asking what are features of IDEs. You can say syntax completion. You can also say runtime environment. So that's where it basically provides an environment for code to be run within an IDE. There's breakpoints, and that's where code runs until a set breakpoint. So you can put a breakpoint for your whole piece of code. You could put a breakpoint at one point, and it'll run up until that point. And that allows you to spot errors a lot easier, because you can keep like closing down the area where the error is. Version control, that's where you can switch between different versions of the programming language that you're using, because with new versions of programming languages, sometimes there are very big differences, and sometimes people don't like them, or they don't work with your old code, so people just want to use different versions of the languages. Error diagnostics, and that's where it tells you a bit more information about the errors of the code, and that basically it just helps you fix them a bit easier. And stepping is where you run through code line by line. Cool. So here is a photo of VS Code. Compiler and translator, you got switched around. Translator and compiler. Oh, I do have it switched around. I don't know why it's switched around. I do apologize for that. So compiler should be on the left side and translator should be on the right side. Translator should... You could use the word translator, or you can use the word interpreter. That's totally up to you. But yeah, sorry about that. I'll fix the slide after, and yeah, it won't be a different link. It'll be the same link, so you can click on that and check it. Oh, okay, done. There we go. That was a lot quicker than last time. That was only an hour. Cool. You guys wanted to go through a past paper, so we'll probably do that in a second. But I'm pretty glad that went relatively well. I'll fix the issues as soon as possible. But for now, you can ask any questions if you want to. What's a lookup table? A lookup table. So a lookup table is when you're doing checks. Let's go back to it. Here we go, a lookup table. So it's where you're doing checks for the inputs. And let's say there are only like 5 different inputs you can have. So there's either there's only 5 different football teams in the league. There'll be a table and it has the names of those 5 different football teams. When something is inputted, it will check them against that. And if none of them apply, that means the input is not meeting the criteria. So a lookup table is just a set of values. Off topic, in business, how many quotes you use? 9 or 12 marks for analyzing. I don't use quotes. It's business studies. You could just use context. Okay. Cool. So, bear with me a few minutes. Actually, you know what? I think I'll do a separate video. Where I just go through a past paper, because I don't know if everyone wants to see that. So you can just do that if you choose. But yeah, that's going to be the end of the stream. It was a lot quicker than I expected. Don't really know why, because there's meant to be more content, I'm pretty sure. But yeah, thanks for tuning in. If you do have any questions, do let me know. It was a bit of a smaller stream compared to last time, probably because I only told people about it like 2 hours ago. But that's fine. The link to the PowerPoint is already posted, so if you look at the description of the video right now, you'll be able to click on that. What should I do tomorrow to revise for paper 1? Past papers. So today is Saturday. Can you change the vid to 1 hour vid? Okay, yeah, sure. Today is Saturday, tomorrow is Sunday, and then Monday we have our first GCSE, and that is paper 1 computer science. So this is all the 2022 students. So yeah, if you do have your paper on Monday, you should be doing past papers. Revision World has all of them. I'm pretty sure, so I'd recommend using that. We the new J277 spec, and there's only like one paper for us available online, which is like the, I don't know, example paper or something. So work through that first, and then you can work through J276, which although it's the old spec, it's mostly all the same. What to do if you've already done all the past papers? You might want to get a workbook. It's quite okay. So what I'd firstly say is, if you've done the past papers, if you haven't got 100% on them, then you're going to need to go through them again, because obviously you made issues, and you should need to keep doing them until you get 100%. With the exam workbook, you could get them. I have the OCR CGP one, which is pretty decent, and I've also got I've forgotten the name. It's called like Clear Revise, I think, which was also pretty decent. But yeah, if you've already done the past papers, then make sure you can get 100% of them. The link to the PowerPoint is already posted. I think that's all the questions. But yeah, okay. Final thing. This exam is before half term. So any students who are sitting 2022 exams, you should be nervous, because the exam is before half term, so you won't have time to revise for it during half term. And that's why I made the video now. Everyone's a bit confused why I made the video now. And it's because I'm not going to do it during half term, and obviously I will be revising from when exams start, so I won't have time to do it else. I won't have time to do it any other time. So this video will be posted permanently, so you'll be able to see it whenever you want. So just before paper 2, I'll probably watch this video the night before. Go to sleep early. Please go to sleep early. You should be getting at least 8 hours of sleep at this point, because exams are here. Don't drink sugary drinks. Look at command words so you can work on your exam technique. Keep your answers contextualized. I didn't do exam advice. That's probably why this is a bit shorter. Yeah, with 5 markers and 6 markers, it's mostly just like if statements. So just get very comfortable with the main things. I think that's pretty much it. I think that's pretty much all I had to say. But thank you very much for tuning in. I hope this has helped. If you do have any questions, be sure to let me know. I'm sorry for the issues with the PowerPoint once again, but I'm going to work on it, and I will fix them immediately. It'll be the same link, so you'll just see them updated in real time. So yeah, thank you very much. I'll see you soon. Best of luck with your exams. Go and smash it. I hope you will. And yeah, the night before Monday, so on Sunday, I recommend watching my previous video. Might put it on 2 times speed or something to go through a bit quicker if you want to. But yeah, I hope it's helped. Thank you very much. Have a good evening or afternoon. And yeah, see ya.